Okay, children. So we will do the next one. Sixth one. Okay. Sixth one is ethanol to ethyl fluoride. This is easy. Ethanol to ethyl fluoride. CH3, CH2F. So this is easy. You tell me first. How do we do this? Ethanol, you will convert it into chloroethane and then Schwarz reaction, isn't it? You have to convert it into a haloalkane and then Schwarz reaction. Fluorine and iodine comes then, if normally they give with alcohol. So you convert it into haloalkane, and if iodine comes, Finkelstein. If fluorine comes, Schwarz reaction. And so when ethanol is there, once we said direct also is there. If iodoethane is asked direct, red phosphorus and iodine, that also we did, isn't it? So here,
Ma'am,
uh,
Kirtana here, ma'am. Your voice is breaking.
others also same. Voice is not clear. Other children voice is clear.
Yeah, ma'am.
Okay, Kirtana, some problem maybe with your net. So ethanol and PCl5. You convert it into CH3, CH2, Cl, chloroethane. And then you put the silver
Ma'am,
fluoride, you will get fluoroethane. Understood? So write it down.
ma'am, could you please repeat? I'm not able to hear your voice.
This is written. Can you see the board? Can you see the board?
Yes, ma'am. Now I'm able to. Last time I was not able.
Okay. So now it is Priyanka. Can you hear me?
Yes, ma'am.
So it is written conversion. This is easy. Ethanol to fluoroethane. So first you convert it into chloroethane or bromoethane, and then Schwarz reaction.
Ma'am,
Ah,
any method to convert into chloroalkane will work, right?
anyone. PCl3, PCl5, thionyl chloride. It is better. Na PCl5, thionyl chloride are the most suitable. So you
Okay.
put that. Anything you can write.
Okay, ma'am.
Okay.
Yes.
Have you
Ma'am?
written this?
Ma'am?
We'll go to the next, children.
Ma'am, am I audible?
Yeah.
Ma'am, could you repeat once more, please? I've again
This
joined.
is conversion, conversion 7. So it is written on the board, ethanol to fluoroethane. So first you have to convert ethanol to chloroethane. So how do you convert? Chlorinating agent, PCl5. You can use PCl3 or thionyl chloride, anything. So you will convert it to chloroethane and then Schwarz reaction. For fluorine, whenever fluorine comes, Schwarz reaction is there, and normally they don't give the chloro or bromoethane, instead they give ethanol. So you convert it into chloroethane by PCl5 and then silver fluoride. Clear?
Yes, ma'am.
Now the next one. Next one is bromomethane. So this is bromomethane to propanone, ketone. CH3, C double bond O, CH3. So here one last year's reaction you have to remember. You remember this propyne. Last year we learned the propyne to propanone. Anybody remembers? See, if we take ethyne, you will get ethanol. Anybody remembers? You have to, which are the reagents? This you learned in 11th. Vishnu Priya, Varshini, anybody remembers? Varsha, Anand? No, then say no. We will not waste time. Anybody remembers the reaction? No. Okay, switch on. Those who are having mic, switch on and say. So this reaction we learned. This is a very important reaction in conversion. Propine directly you can convert it to propanone when you treat with the dilute sulfuric acid in presence of mercury 2 plus catalyst. You remember this now? Directly.
Ma'am, the board isn't visible. Only half of it is visible.
Okay.
Yes.
So this reaction we will make use of. Okay. So this we did last year. We learned this last year, and so you have to convert this bromomethane to propane. Then this reaction we can use bromomethane to propane. You can use. Can anybody say one reaction we learned? We can use sodium acetylide, right? Sodium acetylide. How do you get this from ethine? NaNH2, liquid ammonia, 196 Kelvin. I am not writing that again. You learned that reaction, isn't it? Ethine to sodium acetylide. Yes or no?
Yes, ma'am.
So this reaction we can use and you will get a propyne. CH3C triple bond CH, right? Propyne you will get, and then propyne with, I said, dilute sulfuric acid, mercuric sulfate or any mercury 2 plus salt, then you will get propyne. Clear? This is the 7th one. Any doubt you can ask. Heat is also there. Heat. Have you written?
Yes, ma'am.
So this is the reaction. So,
Ma'am, a minute.
what? Now me.
Wait a minute, ma'am. I'm writing.
Writing. Okay, right. Next one is but 1 into but 2 in. So when you complete, you tell me.
Done, ma'am.
Okay. So next. So here, if you know the reactions, then it is easy. Otherwise, it is difficult. Next one is but 1 into but 2 in. So this is very important. This many times asked. But 1 in 2. 2 in means here CH3, CH, double bond, CH, CH3. Okay. Can anybody tell me? This is frequently asked. But 1 in to but 2 in. Say double bond is in the second carbon. How do you do this?
Ma'am, is it by Marconi?
So this is very important, and here what we do, we will add HBr, any hydrogen halide we will add and then eliminate. So addition of hydrogen halide, if you want the double bond here, second carbon, so then it should be here. The halogen should come, Markovnikov's addition, isn't it? So that is it. So CH3, CH2, CH, double bond CH2 plus HBr. Okay, so here Markovnikov's because I want it here. Then CH3, CH2, CHBr, CH3 added. Now I want to remove. Now it is alcoholic KOH. Alcoholic KOH. Now this will be removed. So when such question comes, you add HBr and elimination. Remove HBr. So you will get CH3, CH, double bond, CH, CH3. Okay?
Ma'am,
Clear? Any doubt?
ma'am, ma'am, am I audible? Could you please shift the camera towards the little left?
Left. Okay? Is it
Oh, ma'am,
okay?
to the left.
Huh?
To the left. To your right.
My right. Okay now?
A little more.
Huh.
Yes, ma'am.
Is it okay now? Now is it okay? Others can see, children? Okay.
Yes, ma'am.
So have you written this?
Yes, ma'am.
Have you done? I will rub.
Done,
Yes,
ma'am.
ma'am.
What, Amitav?
None, ma'am, nothing.
Okay. Next one is 1-chlorobutane to normal octane. So 1-chlorobutane is having 4 carbon. Octane, double. To double the number of carbon, which reaction, children?
Words reaction.
Birth reaction. So 1-chlorobutane. So CH3, CH2, 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 Cl. To octane. Octane means CH3, CH2, 6 times CH3. Isn't it? So what's reaction? I am writing. We are doubling the number of carbon. CH3, CH2, 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 Cl, 2Na plus. From here, CH3, CH2, 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 Cl. 2 NaCl molecule will be eliminated and you will get octane. CH3, CH2, 6 times CH3. Clear?
Ma'am, the ink is not proper.
Not clear. Now clear?
No, ma'am, the ink is little light.
Okay. Another pen I will take. Let me see. Pen I have to buy. Clear, children? So, I'll rub it off.
Yes, ma'am. Done.
So now, next question. Next question. Next question, give reason. So give reasons are also equally important. Give reason, the first give reason.
And there is one more question. There is one more question in that.
Benzene to
Benzene to
biphenyl.
biphenyl.
That is again what's reaction. Okay. Benzene to biphenyl. This is benzene. Biphenyl is this. So first we have to convert benzene to chlorobenzene, isn't it? It is words only. So first convert benzene to chlorobenzene. Chlorine in presence of iron, halogen carrier. You will get chlorobenzene. Then you will take like 2 molecules of chlorobenzene. Again, what's reaction? Ether you should write. Okay. The equation I didn't write ether. 2 molecules of chlorobenzene chlorobenzene in presence of ether. So NaCl will be eliminated and you will get biphenyl. Okay?
Done, ma'am.
Okay. So that is I hope all are writing down. So again, I will not be able to take this again. Okay, so the question answers are very important. You are in 12th standard. I discuss everything in the class. I want you to write it down in the classwork. How many are up to date with the classwork? Are you all writing? Yes.
Yes, ma'am.
Okay. One student is absent. Shashank is there. Then one more is absent. Who is that? Abhishek is there. Who is absent? Saurabh?
Ma'am, Bharti is not there.
Bharti. Okay. Okay. So the next question. Explain. Next 10.12. The dipole moment of Abhishek, good. The dipole moment of chlorobenzene is lower than cyclohexyl chloride. So give reason, I will explain and I will give you the answer. So two compounds. Chlorobenzene, cyclohexyl chloride, isn't it? So this is cyclohexyl chloride and this is chlorobenzene. And so dipole moment of this is less. Can you tell me the reason? Anand is there? Anand is not to be heard. Anand?
Yes, ma'am, I'm here, ma'am.
Are you there, Anand?
Yes, ma'am.
So tell me, what is the reason? Dipole moment of this is less than this. Can you tell me the reason? Or anybody? Vishnu Priya, Varshini, Isha, Palak, so many are there, Ruchi. Can anybody tell me the reason? Why the dipole moment of this is less?
Ma'am, because of the hybridization.
Hybridization. Yes, correct. That is the reason. So here the carbon, the is sp2 hybridized and here carbon is sp3 hybridized. So sp2 hybridized means this carbon is having more s character. So the electrons, what is polarity? Chlorine will try to pull the electron towards itself. So if carbon is having more s character, it will not give easily. So the electrons are pulled more towards chlorine here. That means this is more polar and the dipole moment is more. Have you understood the reason? Have you understood, children?
Ma'am, once more, please.
See, both the compounds you saw, chlorobenzene and cyclohexyl chloride. And here the hybridization is sp2. That means the carbon of this carbon connected to chlorine in chlorobenzene is having more s character because of hybridization. S character more means electrons will be more firmly held to carbon. So chlorine will, electronegativity is that, polarity is that only, isn't it? Chlorine will try to pull the electron towards itself. So that is not happening as in the case of this one. Here the hybridization is sp3, that carbon will give the electrons, give means allow chlorine to pull the electrons towards itself more than in the case of chlorobenzene. Is it clear now?
Yes, ma'am.
Okay, so you write down. See, you write the answer in chlorobenzene. In chlorobenzene, the carbon connected to chlorine is sp2 hybridized. In chlorobenzene, carbon connected to chlorine is sp2 hybridized. and so is having more S character.
Ma'am, could you repeat once again?
In chlorobenzene, the carbon connected to chlorine is sp2 hybridized and so is having more S character.
Ma'am, the carbon connected to?
Chlorine. Carbon connected to chlorine is sp2 hybridized and is having more S character. Have you written? In cyclohexyl chloride, carbon connected to chlorine is sp3 hybridized and is having less S character.
Ma'am, can you repeat that again? In cyclo, that one?
In cyclohexane, as in cyclohexyl chloride, carbon connected to chlorine is sp3 hybridized and is having less S character. Written? So in cyclohexyl chloride, the electrons of carbon-chlorine bond, are shifted more towards chlorine. So cyclohexyl chloride is having more dipole moment. Clear?
Yes, ma'am.
Okay. So next question, next two we have already done. You will write it as homework. Alkyl halides, though polar, are immiscible with water. It as answer is given in the book. I already explained. All of you remember that? So you have to write that. That is already explained in the class, but you will write in the book. Next question, Grignard reagent should be prepared under anhydrous condition. That also I explained in the class. Isn't it? It will react with water to form hydrocarbon. That also you will write yourself. Clear? Now next question, give uses of Freon 12 DDT, carbon tetrachloride and iodoform. You can direct question, you will write from the textbook, homework, okay? 10.13. 10.14 also I will give as homework. I will just tell you, it is very easy. I will just tell you what it is. 10.14, the first one is Finkelstein reaction, right? So that Cl will be converted to I. You will write yourself. The second one is alcohol. It is alcoholic AOH, elimination reaction. Will you be able to write yourself? Elimination reaction according to Zaitsev rule. Okay.
But what about the ethanol and keto?
Ethanol and KOH, it is alcohol. Ethanol is an alcohol. Na? Alcoholic KOH, elimination will take place. Instead of writing alcoholic KOH, they put KOH and ethanol above the arrow. It is alcoholic KOH,
Okay.
right? So it is elimination reaction according to Zaitsev rule. You will write according to Zaitsev rule. So you will write it as homework. Next one is CH3. This type of questions very, very frequently asked. Next one is CH3, CHBr, CH2, CH3 plus NaOH. It is a nucleophilic substitution reaction, isn't it? NaOH and water, that is aqueous NaOH. So Br will be replaced by OH. Clear? Is it okay? Now yes. The next one is CH3CH2Br plus KCN, aqueous ethanol. So it is alcoholic KCN. This reaction Have you learned this reaction?
Yes, ma'am.
So what is the reaction? Br will be replaced by Cn. Isn't it? Alcoholic ACN. Okay, this reaction I will write. This is fourth one, 10.14, fourth one. So CH3, CH2, Br plus KCN, and they said aqueous ethanol. So it is alcoholic KCN. So Br is replaced by Cn. That is the reaction. Okay? Is that okay? So, Prashant, is it okay? Okay. So, next one is that is the fifth one you will learn in the next. It is an ether preparation. For time being, you will leave. Okay, next one. Anyway, it is NaCl will be eliminated and you will get an ether. Anyway, next chapter you will learn. You can leave that now. Sixth one, thionyl chloride, chlorination. OH will be replaced by Cl. Isn't it? And seventh one, peroxide anti-Markovnikov product. And eighth one, Markovnikov product. You can write yourself. You will be able to. Is it okay? So 10.14 is also homework. Okay, if you cannot, it is difficult. I gave you hint, no? So you will do as homework. Is that okay? Okay. So now 10.15 mechanism. Actually, this reaction mechanism is not in the book but since the question is there, simple mechanism I will give you in one step. So for this reaction, normal butyl bromide, okay, KCN. So you can write KCN is an ionic compound and normal butyl chloride. So CH3, CH2, 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 Br. Okay, and so they said ethanol. Okay, so you can say that here you know the reaction. The reaction just now we wrote one. Br will be replaced by Cl. So you can say this out of this ion will come to CH2. This will go. So that is a very simple mechanism. CH2, 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 Cn plus KBr. Got it? It is an SN2. This is, see, my Cn minus will come here, this will go. So you showed the mechanism. Okay, fine.
Ma'am, show the
Ma'am,
board.
could you show the board?
What? Show the board. Okay. Vishnupriya, you asked anything?
I wanted to see the board, ma'am.
Okay. Have you done? Done with it?
Ma'am,
No.
can you please explain once more how the mechanism is explained here?
Mechanism, you know that. Now here Br is replaced by Cl. So this bond will break. Br will go as Br minus. It is understood. But Br will go and Cn minus will come to this. So I am showing this. Arrow showing means Cn minus will come to this carbon. So you will get this. And Br will go as Br minus, will react with the K plus and you will get the byproduct. Okay? Okay. So next one, 10.16, you can do as homework. We have done a lot of like SN2. SN2 means primary will be reacting more than secondary than tertiary, isn't it? So you do 10.16, you do as homework. Okay? 16 you can do, it is not difficult. Okay. Then 10.17. 10.17. Out of C6H5CH2Cl and C6H5CHCl C6H5, which is more easily hydrolyzed by aqueous KOH. So in this reaction, you cannot specify. They did not say about SN1 and SN2. Both way it can happen, isn't it? So you have to say that first. The C6H5CH2Cl is primary and the next one is secondary. So you will say that C6H5CH2Cl will undergo faster under SN2 condition if the mechanism is SN2. In SN2, under SN2 condition, first one will react faster. Under SN1 condition, second will react faster. Clear? Okay, children?
Ma'am, can you please repeat that once?
See, the first compound is C6H5CH2Cl is primary. The second one is secondary. So you know that under SN2, primary will react faster. So most probably when the question comes, they only will mention in SN2, like last one, the reactivity. So they said an order of reactivity towards SN2 displacement. Like that they will mention in the question. If they don't mention in the question, then you will say both. Clear, Chinmaya?
Yes, ma'am.
So we'll go to the next question, children. Next question, 10.18, we have already done. You will do as homework. Para dichloro. Para, because of the symmetry, it will fit more into the crystal lattice. You remember the answer we already discussed in the class. So you will write the answer. Okay. Now, again, conversions are coming. And so, I will do the conversions, okay? And out of that, some one or two are not in this chapter. Later, you will learn. And so, for conversions, I will do in the class, but you have to practice a lot. Otherwise, even though I do in the class, you will not be able to remember. Okay, so I'm doing the conversions, most of the conversions. And so 10.19, we'll go to the board.
Ma'am. Ma'am.
Yes.
When will we do solid state, ma'am?
I can't hear what, Anand?
When will we start solid state, ma'am?
Solid state, I'm waiting. No, actually they send a syllabus and they said there will be reduction in the syllabus. But have you seen the chemistry, instead of reduction, they added solid state and group 15. I wanted, they are saying in our chemistry group, they are saying the syllabus will again change. If the government is saying there is reduction in the syllabus, so the syllabus may again change. And so I am waiting. Suppose the reduction in the syllabus, if they delete that solid state and group 15, so that is why I am not taking. Okay, let the syllabus come. If they, because the changed syllabus, it is increased in chemistry. So we will wait. So later we will take. Okay. Now after this is general principles, metallurgy I will take. And see, by that time, if it comes, solid state is also not very difficult chapter. And but then for P block, group 15 is coming. For you, number of equations are increasing. Group 15 and quite a lot of equations. So that I am waiting. If let the syllabus be clear. Okay. Now whatever I taught the children, you revise properly. And so that is it. Okay, so next conversions. So the first one is propene to propene. So whenever conversion comes, you write propene to propanol, CH3, CH2, CH2, OH. So this is easy. You have to convert it into chloropropane or bromopropane and then add aqueous alkali. This, if you see itself, you will understand. So propene, you convert it into bromopropane, HBr addition, and propanol, you want here OH, that means anti-Markovnikov addition. If you put it here, you don't get the propanol, you will get propan-2-ol. So Br should be here, right? So if if you want Br to come here, then anti-Markovnikov. So CH3, CH, double bond, CH2, HBr, peroxide is required here. Then you will get it as CH3, CH2, CH2Br, anti-Markovnikov addition. Now aqueous NaOH. Aqueous NaOH. So Br will be replaced by OH. CH3, CH2, CH2, OH. Clear? Is it okay?
Yes, ma'am.
Yes, ma'am.
Okay, right. Vishnupriya, any doubt?
No, ma'am.
Have you written?
Yes, ma'am.
Second one, ethanol to but-1,9. Ethanol, CH3, CH2OH. But-1,9, CH3, CH2, C triple bond, CH. Isn't it? Ethanol to but-1,9. And here, can anybody say we have to take a sodium acetylide? If we take a sodium acetylide, we have to convert it into chloroethane, right? Isn't it, children?
Yes, ma'am.
So first I will convert ethanol to ethanol Cl5, chloroethane. Now I will take chloroethane, CH3CH2Cl plus sodium acetylide. Every time I am not writing. You know that preparation from ethyne, sodamide, NaNH2, liquid ammonia, 196 Kelvin. You will get this compound. Okay? That you have to write. That every time I am not writing. So you will get butane, CH3, CH2, NaCl will be eliminated, C triple bond, CH. Okay? Okay, children, plus NaCl. Is it okay?
Yes, ma'am.
Are you all writing? Jay, are you there?
Yes, ma'am. Yes,
Have
ma'am.
you written? Abhishek,
Yes,
have
ma'am.
you written? Pankaj?
Ma'am, can you
Say,
explain the
ask, what
formation
is the
of
doubt?
sodium acetylide once, ma'am?
I didn't understand the question. I can't hear. Say once more.
Can you explain the formation of sodium acetylide once, ma'am?
Sodium acetylide. Who is this? Anand?
Anant, ma'am. Yes, ma'am.
See the reaction I gave you. Na? See, this first day conversion I gave you. Here. Sodamide, liquid ammonia. How many of you remember this? 196 Kelvin. Then 1H will be replaced. Even both can be replaced. Once more you do, both will be. Now we want only one. Okay, Anand, learn the equations, reactions. This chapter you are not learning.
Ma'am, I wrote it wrong, ma'am. That's why I just asked. Thank you, ma'am.
Now it is clear.
Yes, ma'am.
Sodamide, liquid ammonia, 196 Kelvin. So you
Yes,
will get sodium acetylide. Okay.
okay, ma'am.
Anybody, any doubt on this?
No, ma'am.
Okay. So, next conversion. This is again many board question. 1 bromopropane to this. Already you have written. 1 bromopropane to 2 bromopropane. Okay. Since it is very important, I will write again. This we have done. So you have to bring it to second. You look at the compounds. 1 bromopropane to 2 bromopropane. When such question comes, we will eliminate minus HBr, eliminate and then add according to the requirement. Isn't it?
Yes, ma'am.
Okay. So here, first we will eliminate. So CH3, CH2, 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 Br, elimination. Elimination, alcoholic, KOH or NaOH. So this is eliminated. So you will get CH3, CH2, CH, double bond, CH2. Now, according to our requirement, add HBr, Markovnikov or anti-Markovnikov. Here, how?
Isn't it bromopropane?
Propane or butane? Propane.
Propane.
Okay. So one CH2 you remove. Okay. I'll remove one. CH2 Br. So here it will be CH Br CH3. Okay. So here this is the starting CH3 CH2 CH2 Br. So alcoholic KOH. Remove. You will get a propene CH3 CH double bond CH2. Now we will add HBr. Remove HBr, then add. So here it is, here Markovnikov addition, isn't it? So because here it is, Br is coming. So Markovnikov addition, CH, Br, CH3. Clear? Is it okay, Anand?
Yes, ma'am.
So all of you write it down.
Ma'am, can you explain the reaction once more?
See, this is conversion. Bromopropane to 2 bromopropane. So here the change is in the position of bromine. So when such questions come, we will eliminate HBr, then add HBr, seeing the product. So when you eliminate HBr, alcoholic KOH, these are the two reactions, alcoholic KOH. And so when you eliminate, you will get a propene. Now to get to this, we have to add HBr. And the Br is coming here. So it is Markovnikov addition without peroxide. Clear? You have to get to this. First you have to write and you have to get to this. So the Br position is changed. So you eliminate first and then add.
Okay, ma'am, understood.
Now me, is it okay?
Yes, ma'am, understood.
Then say that, no? So
I did, ma'am. You didn't hear. I said before, you didn't hear.
Okay. I'll rub the board. Have you written?
Yes, ma'am.
Next one we have already done, isn't it, Vishnupriya? Benzyl alcohol to, what is it, the next one? Toluene to benzyl alcohol, we have done already. Can you say fast? Toluene on chlorination, heat and light, you will get a benzyl chloride, aqueous NaOH. In the previous conversion, we have done. Toluene to, somewhere we did. Toluene to benzyl alcohol, already done. And next one, isn't it? Jay and Harbaz, here conversion, we are holidays, you are thinking. Are you all writing down? See,
Yes, ma'am.
after the class, I will say. You are thinking about holidays. Leave it. Now, next is, this also is important. Benzene to 4-bromo nitrobenzene. So, benzene. So, if Br is here, 1, 2, 3, 4, this, right? Benzene to 4-bromo nitrobenzene. Okay, any idea? So, this is bromine, para position. So, first we will convert benzene to bromobenzene and then nitration, isn't it? Because bromine is ortho-para directing. And but nitro group is meta-directing. So, we have to convert it into bromine. Okay, so benzene. Benzene bromination in presence of heat and light. So bromobenzene. Now nitration. What is the reagent? Concentrated nitric acid and concentrated sulfuric acid. So you will get nitro group will come to ortho and para, where para is the major product. They asked you para, so you will write this. Clear? Any doubt you can ask on this. You will see the reactant and product and decide what reaction to take place. Okay?
Ma'am,
Yes.
ma'am, 4-bromo nitrobenzene
Yes.
means.
Yes. What is how the structure comes?
Yes, ma'am. Bit
Okay.
confused.
If I put 1 here, 1, 2, 3, 4. Bromine is on the 4th carbon, right? So if I take 1 here, 1, 2, 3, 4. Anyway, nitro group is on the 4th carbon. You can write anywhere, but the structure
Right,
is understood.
Yes, ma'am. Got it, ma'am.
Can I rub it off? Have you written?
Yes, ma'am.
Okay. Next compound, next conversion is benzyl alcohol 2. So this is benzyl group, benzyl alcohol 2. 2-phenyl ethanoic acid. See, ethanoic acid is this, right? This is carbon 1, this is carbon 2. And on the second carbon is the benzene ring. So this is 2-phenyl ethanoic acid. Clear? Any doubt on that? So to get it, first you write ethanoic acid. And this is carbon 1, carbon 2. Second carbon is replaced by a phenyl group. Is it okay? So this is the compound. CH2COOH. Okay, so we have to convert. Clear? And then now, one reaction which you have not learned will come here. See, any compound with a CN group on hydrolysis with acid or base will be converted to COH. You write it in a box. CN group on hydrolysis in presence of acid, mineral acid H plus, will be converted to COH. Even base also it will be converted to COH. Okay, so that you put in, always keep in your mind. CN group on hydrolysis will be converted to COOH group. Have you written this? In box you put, you will remember. So now we will do the conversion. I have to convert this OH into CN. That's it. How will I, can anybody tell me OH how to convert it into CN? Anybody try?
PCl3.
First you have to convert it into chlorine and then alcoholic KCN. Correct? So I am taking the compound C, ethanol. So I will convert it into a PCl file. So CH2Cl I converted and alcoholic KCl. So Cl will be replaced by Cn. CH2Cl. Now the reaction which I said, hydrolysis in presence of acid, it will be converted to CH2COOH. Clear? Doubt, you can ask doubts.
Ma'am,
Ah,
ma'am,
yeah.
should we write?
What? Priyanka?
Yes, ma'am.
Ah.
Ma'am, should we write H2O and H plus both?
H plus is required. If you don't write H plus, mark you will not get because acid. H plus means any mineral acid like hydrochloric acid. That is required. Wherever H plus is there, you have to write. So if you put water, reaction will not take place. You have to put an acid catalyst also. Okay?
Yes,
so that
ma'am.
is why in the box itself I said, water H plus. Any
Understood.
other doubt? Have you understood, children?
Yes, ma'am.
Okay. So that is so
Ma'am, could you show the board for a minute?